Hey guys, welcome to lecture number 5. Today we'll be having practice, just practicing with those FAs. I'm gonna show you a couple of them, I guess quickly, and then just keep in mind that it's all about practice. Okay, so there is no magic formula to know, I guess how to draw them. I found them in my experience, students either kind of intellectually smart. Inclined to do that, so they either immediately know how to draw that, somehow they just pull it from somewhere, from abstract thinking like in their head, or they just practice a lot. Okay, so anyway, let's do it. The first one I'm gonna show you is, I'm gonna take a couple of from the book. Okay. So definitely after this lecture, please finish reading the first chapter. Okay, and yes, and then the next homework will also be about building a face, and we'll probably, I don't know, we'll either practice on Thursday even more, or we'll go to a new chapter. Not sure. Okay. Hold on, let me see. Can't find it. No. Well, okay. Let's start with this one. Okay, so we need to build an FA that accepts all binary strings where zeros and ones alternate. Okay, so build an FA which accepts all binary strings with zeros and ones alternate. Okay, so let's think about this. How can we build that one? Well, first off, we need to understand what does that mean at all, right? So what kind of strings does it accept and what kind of strings it rejects? So that should accept 1 0 1 0 1 0 1, right? And then 0, and then maybe 1, then maybe 0, right? So that should be accepted. 1 0 0, that should not be accepted because it does not alternate. Now 1 1 0, right? Or 0 0 1 1 1, right? So that should not be accepted. Okay. Very important question always, which you guys should always ask yourself: what about very short strings, and what about an empty string? For example, an empty string, would that be accepted or not? So it's interesting, but according to kind of how it works, how the formulation, how the verbiage works in maths, given this description of the FA, right, so that accepts all binary strings where zeros and ones alternate, empty string should be accepted. Okay, so nothing is a part of that language where zeros and ones alternate. Okay. Yeah. So, okay, so 1, would that be accepted? Yes, it should be. 1 0, should that be accepted? Yes. Okay. 0, should that be accepted? Yes. 0 1, should that be accepted? Yes. Okay, and of course, like strings, like longer strings where 0 1 0 1 0 1 and 1 0 1 0 1 0, they're all there. Okay, perfect. Okay, so let's think. What should we do there? Okay, so at the beginning we're going to have one state. Okay, and that state is going to be start state. Okay, if empty string is accepted, that means the start state should also be accepting already. Okay, so we're going to make this accepting. I'm not going to label those states, but you definitely should for the homework. I'm not going to do that to save some time. Okay, so the start state is already accepting, and let's have an arrow here like this. Perfect. Now what's next? So we should alternate on 0 and 1, right? So when we have a transition which has, so let's say like over here, if I have a transition and here I have 0, 1, okay, what does it mean? That means I don't really care if it's 0 or 1, okay? In any case, move to the next state. So like, I don't care what that is, move to the next state. What it also means is that it's not important what it is. I'm not going to try to remember what that is, just move to the new state. Okay, in our case that's not true. We're going to remember what the first symbol is, okay, and then because because once we know the first symbol, we know that the next symbol should be the opposite. Okay, for us it's very important. So that's why that's not how it's going to work in our case. That's why I'm going to delete that. So on 0 is going to go one direction, on 1 it should go another direction. That's the key. Okay. No, the opposite. Okay, that way. Okay, so 0 go to the left, right, and 1 go to the left. Perfect. Okay, what's next? Well, first off, should I be accepting? Yes, it should. Okay, so that should also be accepted. Okay, perfect. So I'm accepting in either case. Now, if I go to the left, if I go to the one side, what does that mean? That means the next symbol should be 0, right? Or if it's not 0, I immediately reject, right? Because if the first symbol is 1, the next symbol should be 0. If it's not 0, so if it's 1, so which means it's going to be 1, 1. In that case, no matter, and it's very important to understand, at that point, no matter what I have for the rest of the string, I definitely know that I'm going to reject. And that's actually that notion of trap state which I talked about last time. Trap state means I'm done. I already made a decision. I'm going to accept it in any case. I'm going to reject it no matter what I see next. Okay, so and that's actually exactly what's going to happen here. So if I go to on the left, and if I see 1, right, I'm going to accept if I immediately stop there. If not, then I need to go on 0, right? So let's say I go over here on 0. That also should be accepted because that does not violate our property, doesn't violate our requirement. 0, right? Okay, and if it's 1, then we're going to go to the trap state, and I'm going to draw the trap state somewhere over here. Okay, perfect. Same thing over here. If the first symbol was 0, right, that means the next symbol has to be 1. If it's not 1, if it is 0, so since we're accepting only binary strings, that means the alphabet is 0, 1, right? So we don't accept any other characters. Okay, so we'll move. No, hold on. Yeah, so if here we have 0, right? That means we have 2 zeros in a row, and that means we need to reject. Am I correct? Yeah, I'm correct. Perfect. 1, okay. That means we go to the trap state, okay. If we have 1, that means we're good. That means we're good, okay. That means we'll proceed to another state, which is accepting as well, okay. And that's it. Perfect. And after that, we basically keep doing the same thing, right? So we just keep tracking of which state is next. If it complies with our property, then we kind of stay in the left wing or in the right wing. If it doesn't, then we immediately go to the middle and we definitely reject. Okay, so if it is a trap state, what do you know about trap states? Trap state which accepts or rejects, right? In either case, trap state always loops on itself. Always. Okay, so we need to draw a couple of we need to draw this thing. Okay, 0, 1. Perfect. Okay, then over here, if it goes from this state to this state, then we can go back, right, on what? On 1. Okay, and now it comes to kind of very similar case as we talked about last time. Let's think about the physical meaning of each state. So if we are in this state, what does that mean? That means the last symbol we read was 1, right? Because if we're coming from over here, the last symbol and the first symbol was 1. If we just like loop around over here and then come back to this state, then the last symbol was also 1, okay? And we're still accepting. If we're over here, that means the last symbol was 0 and we're still accepting. If we're over here, that means we're done, that's it. And same thing over here, right? We're going to come back on 0, right? Okay. And then if we go, so go 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and then if we go to 0, then that's it. We're done, we reject it. Okay, same thing, but the opposite symbol, so we're here on the left. Okay, right. Now, I may, like, at this point, I might be thinking that I'm done, okay? Just keep in mind that in FAs, which is not true for some other machines which we'll be exploring later, but for FAs, what you need to keep in mind is that for every state, you should have arrows going out of the state for each character in the alphabet, okay? What does it mean? That means, let's say we have in our alphabet we have zeros and ones, right? So only two characters, 0, 1. Okay, that means if you take any state, this one, this one, this one, this one, you should definitely have arrows leaving that state with 0 and 1. Okay, otherwise, for example, in this case, you see I'm missing a link here. Well, for example, let's say if I have a string 1, 0, and then 0, right? I don't have an arrow leaving this state with a 0, and that's not correct. That's inappropriate. That's not how it should be. Okay, in this case, the machine will kind of stop and it's going to think, what am I supposed to do? Like, it's not clear what's going on. Like, there is no transition, there is no error. That's really bad. And that's why, again, for every state, for every single circle here, you should have 2 arrows leaving that circle with 0 and with 1. So with this guy over here, with this guy in the, like the start state, right? I have this arrow with a 0, this arrow with 1. For this one I have 0, 1. For this one I have 0, 1. But for this guy and this guy I only have 0. And here I only have 1, right? Because I'm missing another one, right? How to go to the trap state. And that will be, and that's how the final version of this FA looks like. Hope it makes sense. Let's move to a new one. But by the way, in the book, they actually show how to make this FA shorter. So if you guys want to, definitely check it out. I'm not going to do that here. Okay, next example, 1.6. So what do we need to do? We need to build an FA which accepts also all binary strings that begin and end with the same symbol. Okay, so it begins and ends with the same symbol. Okay, so let's think about what kind of strings do we accept. Okay, so begin and end, 0, 1, 1, 1, 0, something like this. Okay, then 1, 0, 1, 1, 1, 0, so a bunch of symbols and then 1 at the end. Okay, so that should be accepted. Then 1, 0, 1, then 1, 1, 1, and then 0, 1, 0, 0, 0, 0. Okay, so that kind of gives us a little bit more idea. Okay, now again, what I found is that it's very easy to find very long strings which are accepted, but difficult to find short ones. There is always some confusion with super short strings. For example, 1, 1, should that be accepted or not? What do you guys think? So 1, 1, does that begin and end with the same string? The answer is with the same character. The answer is yes. Okay. Now 0, 0, should that be accepted? Same thing. The answer is yes. It starts and ends with the same symbol. Now, how about just 0? Should that be accepted? The answer is yes. It starts and ends with a 0. Again, so that's kind of that's what's tricky about those mathematical definitions. They're super short, super concise, like begin and end with the same symbol, but they have kind of all the cases are like all the cases are also based on that description. How about 1? Is that accepted or rejected? That's also accepted because it begins and ends with the same symbol. How about empty string? Empty string. That's also accepted because it begins and ends exactly with the same symbol. No, hold on. No, it's actually not. Well, it doesn't begin, doesn't end. Okay, that's interesting. I think honestly I saw a version of the same exercise where it was accepted. Okay. But in the book, it says it's not. It shouldn't be. Okay, anyway. So empty string is not accepted. Perfect. So the start state should not be accepted. Okay. Cool. So let's start. So what's the logic? Okay, we need to. It starts and ends with the same symbol, but we don't really care what's in the middle. Okay, perfect. So we don't care what's in the middle. It just needs to start and end with the same symbol. So we know where it starts. It starts where you have a start state, but we have no idea how about ending. Where does it end? And that's actually a problem. Okay, so it can end at any moment. We can't really predict how many symbols do we have left, right? So if we could, in this case, kind of, if we knew that's going to be like 5 symbols, right? Then we'll just have start state going on, for example, remembering the first symbol, then, I don't know, looping, some kind of looping on 0, 1, just doing nothing 3 times, right? And then go to the final state. And if that final state, if the transition final state is on the same symbol, then we accept. If it's on the opposite symbol, then we reject. Something like that. But it's not the case here, because if we're in the middle of the string, we have no idea how many characters are left. Cool, let's do it. Let's think. Okay. Let's clear that. Okay. So that's the start state. It is rejecting, right? As we already found out. Okay. Now again, we need to remember what the first symbol is, right? For that matter, we're going to split it. Exactly the same way as I showed last time. Okay, we're going to split it. Because we need to remember what the first symbol is. Okay. We split that, we go to another 2 states. Yeah. And those guys are already accepting, right? Because we found that if the string is just 1, if the string stops right there, then we accept. If the string is just 0, then we also accept. Okay. What happens next? What happens next? So if we are at the top part, okay, so let me kind of draw, maybe, I don't know, no, won't do that. Well, hold on, maybe just go over here and then draw like this transparent separator. Okay, if we're in the top part, what does it mean? That means we need to finish with 0. If we're in the bottom part, lower part, that means we need to finish with 1. Okay. So let's think. So what happens for this state if we go on 0, right? So what should we do with this state if we see the next symbol to be 0? We still should accept, right? So we can probably move to another state we should be accepting, or we can just kind of loop, right? Because this string is what accepting, right? Yeah, so we should probably loop. No. Okay. So we're looping on 0, right? And we're gonna do exactly the same thing for this guy over here. We're gonna loop on 1. Okay. Perfect. Now, if we're in the top part, right, and if we see 1, what should we do? We definitely should move somewhere else, because if that is the last symbol, we can't accept, right? So we should go to some other rejecting state. Okay. One. Okay, and here we'll go on 0, right? Okay, perfect. But now, if we're in the top part, right, so we begin and end with 0, right? So if we go from 0 to over here, then we'll loop a couple of times, right? We still accept. Then we'll go to 1, right? Is that a trap state or not? So do we have a chance to get back, to be normal and win this game, to get back and win and be accepted, right? The answer is yes, we still have a chance. If we, for example, go here on 0, then loop a couple of times on 0, then go to on 1 here, and then if next we have 0, and that turns out to be the last symbol. So in that case, hold on. Good. Okay, so let's see. if we have first symbol to be 0, go over here, loop a couple of times here on 0, then go on 1 over here, right? Then do we have a chance to get back to normal and to come back and win this game, right? So to finish up with the 0, do we have a chance to still be accepted? In other words, this state, is that a trap state? The answer is we still have a chance, right? We don't have, it's not a trap state, right? Because again, if we go from here to here on 0, loop a couple of times, then, or not loop, then we go to here on 1, right? If we get a 0, we'll still come back over here, and if it happens to be the last symbol, then we accept, right? So we can just move over here on 0. Same thing. Over here with 1. And I think that's pretty much it. No, not it. Okay, so same thing. Like, do we have transitions on 0s and 1s for both of these? For all of these states, okay? So here, right, we have arrow with 0, arrow with 1. Here we have arrow with 1, arrow with 0, and here we have only arrow with 0, but with 1. Sorry, but what happens if we are in this state and we receive 0, right? So we still cannot accept. We cannot go over here because we need to end with a 1. That's why we will probably have to loop here. Okay. So we're gonna loop here on what, 0, right? So we should not finish with 0, and we're gonna loop here on 1. That's it. That's it. So again, if you just at the end of solving this such exercises, what I recommend doing is to write out different strings which should and should not be accepted, especially the edge cases, and then just kind of run those symbols against such FA, and just to make sure that it works correctly, works properly. That's it for this one. Moving on. Okay, let's do a couple of exercises from the end of the chapter. Okay, which one? Let's do 111. Okay, so construct an FA that accepts all binary strings with precisely 3 ones. Okay. Binary strings with precisely 3 ones. Okay, so exactly 3 ones, not 2, not 4, not 0, not 1, only 3 ones. Okay, so a question comes in sometimes from my students is, but what about zeros? Okay, so there are 3 ones, but what about zeros? And again, that's how the mathematical scientific world works. This definition has everything you need to know. And a lot of times I remember when I was taking a similar class, similar exam, professor would refuse answering such questions because you need to be able to understand, students need to be able to understand the answer to that question just based on this definition. Okay, so based on this definition, you should be able to conclude that zeros, number of zeros, do not matter, doesn't matter at all. You can have 0 zeros, you can have billions of zeros. It doesn't really matter where they go between ones. It just that nobody cares. So let's talk about. Let's come up with a couple of strings which should not be accepted. Okay. So 3 ones, right? Okay, so that should be accepted. How about this? Should that be accepted? The answer is yes. How about this? Should it be accepted? Yes. 3 ones. Perfect. How about this? No, that shouldn't be accepted. It doesn't contain 3 ones. How about, I don't know, this? Should that be accepted? No, because, well, yes, because it has because it has 3 ones. Okay, so that should be accepted. That's perfect. How about empty string? Does empty string have 3 ones? No, so that's why it should not be accepted. What else? I don't know, just 1, right? Should that be accepted? No, because it doesn't have 3 ones. Just 0, should that be accepted? No, because it does not have 3 ones. Okay, again, hope it makes sense. Okay, so let's try to build it. in this case, what do we have important? We definitely need somehow to count number of ones. Okay, we need to count them. We need to count 3 ones. 1, 2, 3. Okay, and the way it is done in a phase is the following way. Okay, state, 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 I think. Okay, transition, transition, transition. Then 1, 1, 1. Okay, that's how you do that. So if you're in this state, right, that means you didn't encounter any ones yet. If you're in this state, that means you encountered 1, 1. If you're here, that means there were 2 ones. If you're here, that means you had 3 ones, right? Now, if you want to count 4 states, you just like have the same chain of 4 ones. Then you create the same chain of 4 ones, or 4 states. 5 states in that case with 4 transitions. If you want to count 1 billion of ones, same thing. Create 1 billion and 1 states with 1 billion transitions in between, and then and then you would count like 1 billion of ones. Okay. So what do we know? We're coming from the left here. If we're here, we reject. Here we reject. Here we reject. Here what do we do? We accept. Okay. What do we do with zeros? Nothing. We just loop, right? So zeros don't really matter. Okay. Nobody cares about zeros. Okay. 0, 0, 0, 0. Okay. Yeah, perfect. And a lot of times when I give it to my students, they stop at that point. Okay, but remember again the same trick. You need to keep in mind that each state needs to have a transition on both of the symbols leaving that state. Okay, so for this state we have 1, 0. For that state we have 1, 0. For that state we have 1, 0. But for that state we only have 0, right? And that's actually a good point. What if we have 4 zeros? 1, 2, 3, and then the 4th one. Okay, what does it mean? That means if we have a 4th one or 5th one, 6th one, we automatically reject. Okay, so that becomes a trap state. We reject in 100% of the cases. So what do? We just create one more state, which is a trap state. Draw a circle here. Okay. 0, 1. That's it. Okay, and it's going to be rejected. Okay, there is no way from the trap state. There is no way to come back. Absolutely no way. Cool, hope it makes sense. Let's maybe take another one more, and then we'll stop. Which one? I'm trying to think. Yeah, by the way, yeah, so of course, since I solved so many of those, I can solve them like very, very quickly and without like even looking anywhere. But when I was just starting out, I would spend a huge amount of time for each one of them. Okay, so if you guys feel lost when you're doing the homework, it's totally normal. Just keep that in mind. I was exactly the same way, but now I just solved like thousands of them probably. Not sure. Constructing the Fey. Yeah, this one. I like this one, by the way. Constructing the Fey that accepts all strings of A, B, C, so not 0, 1 anymore, that contain an odd number of A's. Odd number of A's. Yeah, so how to count odd and even number. Yeah, let's talk about that. So build an FA which accepts all strings of A, B, C with an odd number of A's. Okay. Perfect. So first off, again, let's think about what kind of strings would accept, would reject, just like throw them out there. Odd number of A's. Okay, so A. That should be accepted. AA should be rejected. AAAA should be accepted. Now, ABC. that would be accept because it's 1A, right? So which is odd. And then A, then BC, BC, A. That will also be accepted. So basically, we don't really care about BC where they are, right? We have we don't care at all. We just really care about how many A's we have. Then I don't know what else. Yeah, empty string, by the way, empty string. Would that be accepted or not? Right. So the question is. Again, a lot of times students ask me that, and it's the same thing. You need to look at the definition and you need to conclude that just based on the definition. So in an empty string, how many A's do we have? We have 0 A's there. Is 0 an even or odd number? 0 is even. That's why empty string would be accepted. Okay? That's it. Yeah, that's it. Okay, perfect. So we need to, we just need to count how many A's we have. We literally need to count how many A's we have, right? We need to understand. We need to be able to understand if it's odd or even number of them. Okay. So let's draw that. I think we're gonna have only like a couple of states, maybe 2. I don't remember. Okay. So we start over here. Do we accept or not? Do we accept an empty string or not? The answer is yes, we're going to accept it. That's why this is going to be accepted, right? Yeah, so since we don't really care about BC, right, for all the states, BC is going to be, we're going to just loop on that, on the same state on the BC, right, because like who cares about them? Okay, now, but what matters is how many A's we have, right? So if we have 1 A, we don't accept. We have 2nd A, we accept. If we have 1 more A, we reject. 1 more A, accept. 1 more A, reject. 1 more A, accept. That's how odd even works, right? Divided by 2. That's why in this case it's going to be pretty simple. We're just going to alternate between the states on A. That's it, right? And this guy is going to be rejected. So if we have nothing, we accept. If we have A, we reject. 1 more A, accept. No, sorry, odd. No, odd number of A's. Okay, that's different. That changes everything. We need to have odd number of them. Okay, odd number. So it's the opposite. We need to accept here. Perfect. Okay, so we do not accept empty string. Okay. Perfect. So we come over here, if we see A, just go over here, accept. If we have 1 more A, go over here, like 3rd A, right? Then we reject. 4th A, accept. 5th A, reject. No, sorry, 6th A. Yeah, 4th A, reject. 5th A, accept. 6th A, reject, and so on. Now, again, it seems like it's it. Let's just think about if we have make sure if we have all the states with leaving transitions on all the symbols of the alphabet. We have A, B, C here. For that state, we have A leaving that state, B, C here. For this state, we have A going over here and B, C looping. Okay, perfect. So we have all it covered. So that seems to be it. I mean, I don't have any answer, but I think that's the answer. That's what it should look like. Okay, cool. That's it for today. I'll see you guys next time. Please prepare for the quiz. The quiz will be on this, of course. I'll see you guys later. And please submit the notes by the end of the day. Bye bye.